now. So I think we are now live on YouTube as well. Welcome everyone. So today we have Joana Gomes de Sá. It's a long time waiting, talking to Joana, I think maybe 1 year or more. And because of that, or probably that's my excuse, the first thing when I announced the talk, I put her affiliation wrong. So before she used to work at Nova, but now she's at LEAP. So Joana, she has a degree in physics and PhD in system biology, but now she's the PI, the principal investigator of the SPAC lab, SPAC from Social Physics and Complexity at LEAP. She's still associated with Instituto Superior Técnico in the University of Lisbon, but she writes soon in the future will be just working at LEAP. And in 2019, as Joana won a grant, a very big grant from ERC to study about how social human behavior interact based on social media data, on misinformation. And I think this is part of what she's gonna talk to us today. So I don't want to take much long time. Joana, thank you for accepting this invite and for being here with us. Do you have any preference about the questions during the talk? We'll leave for the end.
Whatever you prefer.
Okay, so if you have any question, you can put on the chat, you can raise your hand. And if you're on YouTube, you can post your question in the chat and I'll bring the question here. Okay, thank you.
Thank you very much, Leo, for the introduction, especially for the invitation. Yes, it's been we've been talking about doing this for quite some time, and I'm really grateful for your thinking about our work for these talks that are that sometimes I follow, and they're typically very interesting. So I hope I won't disappoint you or the audience. And I'm gonna hope that most people didn't read the abstract, which is typically the case, and I'm gonna deviate a little bit from what was originally planned, exactly because it's been quite some time, and I wanted to show you a little bit also of our more recent work. So I'm going to be focusing on the question of misinformation and fake news, which is something that we've been working on in the group for quite some time. And we actually work on two different problems in the group, but we use a very similar approach. So we actually work on disinformation, and we also work on infectious diseases, and we've been doing this for quite some time. Actually, we started with infectious diseases, and then we moved to disinformation because conceptually we can think about them in parallel. So we can think about fake news as being pathogens, and we can think about the humans that believe or don't believe or share or don't share the fake news as being hosts that can be infected or not infected or infectious. And then we can think about the environment in a way, or what is now the natural environment of humans, which are social networks or the life online. And what we try to do with it, and now with COVID, it's very easy to explain when, like Diogo was saying, when we first started with this project, I wrote this grant in 2018, and we got the project in 2019. It was much less obvious, this relationship. I think now people are much more accustomed with this idea that you can have these pathogens over us, that different hosts can have different susceptibilities. So I might be susceptible to malaria, but because it's not around, I personally don't have to worry about it on my day-to-day. Even within the same environment where the pathogen is spreading, some people are going to get it and some people are not going to get it. So the role of these three factors is very important for both infectious diseases and for disinformation. And here, of course, the parallel is that I can believe some fake news and not others. And if I'm in a network where no one is sharing this particular piece of fake news, I don't have to worry. And then the type of mathematical or theoretical framework that we use is actually very common between both. But today I'm only going to be talking about the top part of what we do in the group. And I'm going to try to give you two examples of how we are trying to approach this problem in a general way. And I'm going to be giving an example of why some humans might be more or less susceptible to some fake news. And this is the first part of the talk in which I'll be talking about the Dunning-Kruger effect. And there's going to be another part on what we see online, what we see in our environment, how that might influence as well our perception of the world and make us more or less susceptible to disinformation. So this is the general roadmap. I'm going to divide it in two parts. And this is the research group, more or less now. This part of the group is working mostly on the health part, or the infectious diseases part. This here, Christine and Angela and Simona work mostly on the type of work that I'll describe in the first part of confidence. And then I'll also be showing the work of Edish and Jose on understanding, on using bots to do auditing of our browsing behavior. And these are the fun engagements. Okay, so I'm going to start with a real tweet from an example early 2020, so February 7, 2020, when the COVID pandemic started spreading. And this was someone who went to their pantry and they realized that they had a bleach there, and that the bleach said on the back of the package, it said that it was effective against coronaviruses. So for many, many people, the COVID pandemic was the first time that they heard about coronaviruses. So they thought, like, how is this possible? Okay, so this was the real tweet, and it says, so it's been around. How did they know about a virus we knew nothing about? Okay, so this now was turned into definitely evidence of a government conspiracy. Okay, so the Lysol labels are a proof that the government knew in advance about this virus. And many of these things were circulating in the sense of conspiracy theory. And then this person also adds, coronavirus is nothing new. Okay, and it's true, it was nothing new. This specific one was the SARS-CoV-2, but of course we've had human coronaviruses for thousands of years evolving with us. And a little Wikipedia search, or just like going on Google, or would have made this person realize that yes, they are nothing new, they exist, and the Lysol label was talking about a different type of coronavirus. And that this requires, it seems very obvious what I'm saying, and I'm going to say a lot of things that I hopefully are going to sound very obvious, which is the idea that why would they jump into a conspiracy theory before going on Wikipedia? And the idea is that you need some sort of humility to realize that you don't know. So the step of, I don't know enough about this, so I'm not going to comment, or I'm going to try to find out a little bit more, implies or requires an humility step. Okay? And this very human characteristic of disinformation spreading is something that we had, that it had been observed. And I'm going to focus on one paper that raised a lot of discussion in 2018 that made the Science of Cover. The cover of Science, in which Vosoghi and Aral and colleagues looked at millions of tweets during the 2016 US elections, and they found that the falsehood diffused significantly further, faster, deeper, and more broadly than the truth. So they were comparing real news with fake news. And then they found something that was particularly interesting and that raised a lot of discussion, which was that the fact that there were a lot of bot accounts on Twitter accelerated the spread of the true and the false news, but they did it at the same rate. So it was as if the bots could not distinguish between real and fake. They would just propagate them proportionally the same. It was the humans that were more likely to spread it. And if you think about coding from the classical way, I'm not talking about machine learning or anything like this. If you wanted to program a bot to have a preference for fake news, it's not easy. Like, code the classical way, like the type of background information that you have to give the bot. How do you distinguish between them? What are the reasons for you to identify one and not the other? It's not easy because we are not so good at knowing that. We need a lot of context, you need a lot of knowledge, and we have a lot of biases. And probably the spreading of fake news is building on our biases. So I'll say another thing that it seems obvious at the first step, and at the first view, and I hope it's not obvious at the second one. Okay. So this was the figure saying that it was faster, blah, 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 blah. And this is when they looked at emotions using sentiment analysis, but what the emotions that were elicited by the titles of those fake news. Then the green is true and the red is false. And what they saw is that the gap was bigger and that the falsehood was even spread more if the titles elicited surprise or disgust. And typically, like again, the first our first idea is that okay, yeah, that makes sense, right? So like if they're very shocking or very disgusting or very surprising, people are going to share them more. But again, if we were rational agents, not only we should have this on switch or off switch saying like, I don't know enough about this, so I'm not going to share. We should also have something saying this is so surprising and so shocking. Maybe maybe it's not true. So I should doubt it more and not less, and spread it, not necessarily spread it more. So this is the model, okay, from basic psychology. This is the perfect metacognition, and metacognition here means that I know how much I know. Okay, so there is knowledge about how much I know. If I know a lot, I know that I know a lot, and if I know little, I know that I know little. Okay, so if I were to plot this very simply on how much I know and how much I think I know, okay, it should have some sort of a straight line. So it should increase more or less linearly, how much I think I know. Okay, but then there was this thing called now the Dunning and Kruger paper that is now called the Dunning-Kruger effect, that it's been like everyone's talking about it. What they saw was that when they measured knowledge versus confidence, how much people think they knew, it was more of a flat line, depending on the examples, and I'm going to show you the original paper. Depending on the test that they did, this line was kind of like very flat, or it had some sort of a positive linear relationship. But the most important finding that they had was that the biggest gap between how much you actually know and how much you think you know was bigger at lower knowledge. So the less you knew, the bigger this gap was. And then the more you would increase your knowledge, this would be lower and lower. And then sometimes you'd even be underconfident. Like, so the experts would underestimate how much they knew using this sort of system that they used. Okay, so these are images from the original paper in the late 90s. And basically they did different tests. So this is humor, this is logical reasoning, this is grammar, and this is also logical. This is slightly different, but similar to this one. And but basically what you have here is always the theoretical prediction in a way, so that the knowledge and confidence will grow more or less linearly with knowledge. And this is how they perceive themselves. Okay, so typically it's either flat or there is some sort of linear positive correlation, but the biggest gap is always at these lower knowledge levels. And I think, okay, so I'm gonna give you just one example of the type of test that they do, and I'm gonna try to do it briefly. So let's say that you have these these four cards, and the cards have on one side a number and on the back side a color. Okay, and this is the sentence. The sentence is, if a card shows an even number on one face, then its opposite face is orange. Okay, so they give you this sentence, and you have to turn two cards to test if this proposition is true. So I'm going to give you a second to think about it, and these are the options. Oh, there are many other options, some are very obvious. So you can only turn two cards. And the majority of people, when they take this test, they answer D, 8 and orange. Okay. And the correct answer is E, 8 and blue. Because if you turn the orange card, you cannot falsify your hypothesis. Okay. If it were even, you'd know the same. And if it were odd, here it doesn't say that all orange cards have an even number. It says the opposite. It says that if they are even, okay, then they have to be orange. So you'll have to turn the blue and make sure that it wasn't even. But automatically, like the way our brain, like these switches that I was talking about, of on and off, and giving us the most intuitive answer instead of giving us the right answer, are the type of things that then we have biases that we are unconscious of. And this is the type of test that they did. And then they asked people, do you think you got it right? And lots of people said that they thought they got it right, and actually they didn't. Right? So, and the ones who were worse at this test were as confident as the ones who were better at this test and other types of tests. Okay, so, but now this has been, like, the Dunning-Kruger effect has been subject to much criticism. And do interrupt me if you have questions or if something's unclear. And one of them is that all of these confidence metrics are self-reported, meaning that I ask you, how well do you think you did? So there are many reasons why you could tell me a lie about it. Maybe you're just embarrassed. You know you didn't do so well, but you don't want to say it. So you say, oh, I think I did like average or better than average. Right? The other thing is that there's a calibration problem, because typically they don't ask you how well you think you did on an objective scale. They do it on a comparative scale. So is how well do you think you did when you compare it with others? So 100 people are taking this test. Do you think you did better or worse than the others? And then you don't know, when people overestimate how well they did, if it's because they think they did better, or it's because they think the others did worse. So we don't know if it's a numerator or a denominator problem. Okay? And then there are these problems of sampling effects, of course, because many of these studies were done for many, many years in small populations, college students in elite colleges in the United States and so on. And many of them don't replicate so well outside. And then they always do these comparative scales, a little bit like I was saying, both in X and in Y, in which they ask you, in which quartile do you think are going to fall? Do you think are better or worse than average? Or it's always compared to others. Both and they plotted both the knowledge and the confidence like this. And then there are analytical problems. So there was a paper, and more recently, in which what they did was that they simulated data of people, of not real people, but of IQ tests. And the only thing that they did was that they simulated a certain probability of people getting a certain value of IQ, and of the one that they would say that they will get, or the machine would have a better than average effect. So for IQ, the average would be 100, but if you just have people say a little bit more than usual, but typically people don't say that they have 100. They don't feel like they are on the average. So if you just add the probability that they're gonna say that they're that the average is going to be 125 instead of 100, you get something that reproduces quite well the Dunning-Kruger effect, in which people overestimate. And these aren't real people, it's just a simulation. So there has been this idea that just a regression to the mean or better than average effect could explain the Dunning-Kruger effect, and it's nothing spectacular. And then of course there's this issue of binning, which is typically you don't have a perfectly normal distribution. You have the respondents distributed in a completely in different ways, and by looking at quartiles, you might be hiding this variability. So what we wanted to do, because we think that this confidence is important for understanding why people believe in this information. Like I was saying, you need to know that you don't know for you to not share or not to fall for this. We wanted a metric that would be not self-reported, that it would involve no comparison with others, with peers, with a large sample and looking at the full variance, so that we wouldn't have any of these problems or many of these problems that we are describing here. Again, and this is what we thought. So this is the idea. For something like the Dunning-Kruger effect, if we think about any questionnaire, any question, for which there is a true and a false and a don't know option. Okay, so for any situation, you can say true, false, don't know. And for which there is a correct and an incorrect answer, which is true, for instance, for most scientific knowledge questionnaires, we can use it as a proxy for confidence. And I'll explain what I mean. So let's say that I ask you, the Earth revolves around the sun. Okay? And you can say true, false, or don't know. If you were a completely rational agent, again, if you know the answer, you'll get the correct answer. If you don't know, you say don't know. But if you think you know, but you don't, you're going to get it wrong. So we can use the ratio of incorrect answers as a proxy for confidence. It's this place where you think you know, but you actually don't. So you get them wrong. So basically, and these are just an example. If I'm plotting here the fraction of the don't knows to incorrect, in the perfect metacognition model, this is as the percentage of correct answers increases. So for 0 correct answers, I only get don't knows or incorrect answers. And in the perfect metacognition, I will never have incorrect. So I only have everyone answers don't know. All of the answers that I don't get correctly, I answer don't know. If I answer randomly, I'm going to have a flat 50-50 of correct and incorrect and don't knows for each bin of the correct answers. And according to the Dunning-Kruger, I should have more incorrect, a higher proportion of incorrect than don't knows in the lower knowledge bins compared to the higher knowledge bins. So I should have some sort of a linear or close to linear relationship like this. So now the work that I'm going to show and the results and the approach are the work of 3 postdocs in the group. Federico, who has a background in physics, Simone, who has a background in neurosciences, and Cristina, who has a background in psychology. So PhD in physics, PhD in neuroscience, and PhD in psychology. And the group that I've been leading, the SPAC group, is very multidisciplinary. Like it's very, we'll have people with all these different backgrounds, and you'll see this is just an example. And they were working together to try to solve this problem. Okay? And this is what they did. They collected 3 large-scale surveys that include knowledge questions of the true, false, don't know format. Okay? That ran in Europe and United States over a large period of time. And in total, we have close to 100,000 respondents. Okay, so we don't have to worry about pinning so much. And they have different knowledge questions, but all in this format. And I'm going to guide you through the results. So in this first one is very similar to what I was showing you before. Here are the number of correct answers is what you see in orange. Okay, so 0 correct answers you have no orange. All of the correct answers you have all orange. And the ones that are not correct, they can either be because people said don't know, or because people guessed them incorrectly. Okay, again, does the Earth revolve around the sun? All of these 12 questions. Some people got them all right, some people got them all wrong. If they got them all wrong, they either said, I don't know, or wrong, meaning not correctly. They either got them all wrong or they got them incorrectly. And I remind you that the Dunning-Kruger effect predicted that would have a bigger ratio of incorrect to don't know in the lower knowledge bins than what we observed. So actually now if I eliminate the orange, and if I just project the green and the purple here, okay, so this is the same as not having the orange because it's already on the x-axis. So I just project it there. This is the linear projection. Just drop it. And what we find is that we always get, for all of these surveys, we get a quadratic relationship. So if I calculate the calibration error between what we would expect from the metacognition model, which is no incorrect answers, you either get it right or you say don't know. And the number of incorrect answers that we get is like inverted U shape. Inverted U appears for all surveys. And what it means is that the calibration error peaks. So where people make more mistakes and proportionally give more incorrect answers than don't know answers, happens at intermediate levels of knowledge. It's not here, it's not in the lower knowledge bins. It's always at the intermediate to lower or really intermediate knowledge. So we couldn't really explain this because this is not what was expected from the metacognition model, nor the Dunning and Kruger effect, that this confidence gap is higher at intermediate levels of knowledge. But this could be specific to our indirect confidence metric. It could be specific to science-related questions because that's the questionnaire that we're using. Then it could be specific to non-controversial issues such as the Earth revolves around the sun, instead of talking about things like genetically modified organisms or vaccines and things like this. So what we did was that we already had these 3 surveys that I mentioned, but we constructed a new one. And we had the same questions as in the Eurobarometer in the same metric. So we could use our true, false, don't know, and our indirect confidence metric of the proxy, using proxy of the number of incorrect answers. But we also included the direct confidence metrics, exactly like Dunning and Kruger do, asking people how many of these questions you think you got right. And then we also got a large data set from a paper that was published in 2019 that saw evidence of the Dunning-Kruger effect in opponents of genetically modified foods. So they asked genetics questions, knowledge, scientific knowledge, asked them how many they thought they got right or how much they knew about the subject, and then they classified how many they got right and how many they thought they got right. So it was classic Dunning-Kruger effect. And this one was on a controversial issue. And we repeated the analysis. Okay, so this is for our survey, and now here we have a much bigger error bar because we have a much smaller sample. So here we're talking about 1,300 versus the 84,000 that we have for the Eurobarometer, but the trend is exactly the same. So the peak of the fraction of incorrect happens at intermediate knowledge levels and not for the lower ones. And to our surprise, this was the same for the Dunning-Kruger type of metric. So we also have the peaks and the shaded areas. It will be for the lower to intermediate knowledge levels and not for the lower for the ones where people know the least. Okay, so we have these consistent intermediate knowledge levels being the ones that overestimate their knowledge in all studies and in both metrics. And here's what we think is happening. And it took us quite some time, and now again, I think it's it's obvious, but it took us a while to figure out what was going on. And it has to do with what I was telling you in the beginning, that many of these distributions are quite skewed. So this is for the survey that I was showing you. This is for that we did. This is for the Eurobarometer. This is for that paper where they looked at genetically modified foods, and they are non-normal. So what happens is that the Dunning and Kruger and most of the literature after them, they plot everything in quartiles. So the first quartile hides a lot of variability in many of these studies. And what happens, and this is these numbers of the 1,000 are much similar to the ones that typically are used in the studies than these many thousands that we used here. So what happens is that if I were to plot the calibration error like I showed you before, so this is for the Eurobarometer, this is for Fernbach, this is the dashed line behind, and this is for ours. If I were to plot it using the quartile system that we've seen before, this effect disappears. We no longer see that the lower knowledge beings don't overestimate by much. It actually feels like that is lower knowledge beings to intermediate knowledge beings overestimate by a lot. Okay? Because we are not seeing these ones yet. So, and we think this is here, they look very similar, and they look very similar to us here as well. But in fact, they are quite different if we were to plot over the full variance of the distribution. So what we think is going on is really that this is in a way hidden by the way the data was plotted. If we plot a set of quartiles, if we use a full distribution, we don't see the Dunning-Kruger effect anymore. What we see is this U-curve, or inverted U-curve, this quadratic relationship, in which the people who know very little, they don't overestimate by much. And the people who know a lot, they almost don't overestimate at all, which is expected, is the people that know a little that overestimate or that overshoot by a lot. So we see no evidence of the Dunning-Kruger effect if we don't plot it with quartiles. And this has implications for attitudes towards science and science in general. So in the second part, we looked, this is for the Eurobarometer and also for the study that we did, at questions such as, we depend too much on science and not enough on faith, or because of their knowledge, scientific researchers have a power that makes them dangerous, and asking people if they agree or disagree with these sentences. And what we found is that the people that are more likely to agree that scientific researchers have a power that make them dangerous because of their knowledge also peaks for these intermediate knowledge levels. Intermediate knowledge, very high confidence. And this was, there are, I think, 13 questions, 10 to 13 questions, I'm not sure, of these attitudes towards science. And this is a very consistent effect. Every time that the most, what could be argued to be the most negative attitudes towards science typically appear at this intermediate knowledge piece. Okay, so to sum up this first part and to interrupt, if you feel like it, I left plenty of room for questions. We think that we have identified a non-linear relationship between confidence and knowledge that was never identified. So metacognition, Dunning-Kruger, random answering, most of the simulations and hypotheses before give you a linear relationship depending. The direction can vary, but it's typically always linear. And we find that accuracy, meaning how good you are at estimating your own knowledge, is lower at these intermediate knowledge beams. So you overshoot or you make more calibration errors at the intermediate knowledge beams. And we think that this effect is hidden unless we look at the full distribution. We are, this hasn't been published, we are submitting this week or so. So if you have questions or comments, it will be very, very useful. I've been suffering from probably insecurity bias, because it's very difficult for me to believe that it hasn't been seen. So I keep thinking that I missed something that is very obvious. So I'll get the feedback would be very appreciated. But we think that at least in the case of scientific knowledge, which is the ones that we looked at, we do find that a little knowledge is worse than some knowledge. Okay, so it's not giving some knowledge or having some knowledge makes you much more likely to be overconfident. So the idea is that confidence grows much faster than knowledge. Knowledge will grow linearly, but confidence grows much faster. And if you know a little, you overestimate. And of course, this has implications for public attitudes towards science and science communication, because the entire concept behind science communication is that you should give more information to people, and you should give more knowledge to people, and then people will love science more. But maybe if we oversimplify scientific knowledge, or if we give the illusion that that when we give a little bit of information, now everyone's an expert, we might have a very negative feedback that is unexpected. So I don't know if you have questions about this part, because I'm about to shift gears.
I have a quick question. Like I was wondering, when you talk about why people share things, you could just do like a very quick search on Wikipedia and they find the result. And I have this like every week. I have WhatsApp groups with my family, and they already know that they don't know, but they start saying, okay, I don't know if that's true, but I think worth sharing because there is some new scam or new drugs going on, and they just put things there. So I don't know if this is something that we always had, but we never measure, and maybe it was not like very harmful for society because everyone could share some concerns because they hear here and there, but that thing was like so concealed in small groups, never have like bigger scales. But now that we have different tools and different ways to spread, now this become a problem. So the problem is not necessarily the way we change, but the tools that we have.
So I don't know. The way we study this problem is that we really think that there's something very human about trusting in something very human about these biases, right? Like our hypotheses in the project are very psychology and behavioral based. And so one hypothesis now that we're testing is, do these people of intermediate knowledge, overconfidence, are they actually more susceptible to fake news? Okay, or to disinformation? Because now we have a very specific testable hypothesis, and then we can go ask, okay, why? Okay, why are these ones more susceptible? In terms of what you're saying about the scale, I think that's very interesting, and this is something that we also talk a lot about, which is, okay, I'm going to give a very crazy example, but it's before in the villages, there was always like this crazy person, right? Every small town will have kind of like a crazy person that everyone else dismissed as being kind of crazy, maybe a bit drunk, maybe not very stable, something like that. And you knew, and you kind of like dismissed this person. You would not take so seriously what they thought. You knew they were not educated. You knew that they did poorly in school. You had all this story of their background. But now it's again a problem of distributions, right? Like, so now the tips of the distribution are visible, the same way that now we can see the tips of our distributions because they are have so much data. Now all of these tips of the distributions are now visible, and they can amplify themselves because now all of the crazy people from the village know each other and connect each other, and it seems like now they're a thing. Now they're a group. They're not just like isolated. So this idea of like being able to look at the tips of the distribution and seeing the impact on the rest of the network, that's something that we care a lot about when we think about this part that I'm going to be talking. I won't be talking about that, but it's something that we've been discussing. And so Lilia, another postdoc, senior postdoc researcher in the group that I know you know, she's really been looking at the distributions of Twitter cascades and what happens at the tips, and how, and one of our goals in the future is to really see the impact of very low probability events.
And also, like, related to this distribution, I think a few years ago, or maybe a few decades ago, when we have like some anecdotal stories about anything, usually people would respond by the common sense. No, this is not possible. And people will believe that's the common sense because that's the truth, the visible truth, even though probably you have like a very few specific cases where that fact is not true. But nowadays, I think it's easy to find all these exceptional cases. So now virtually everything is possible. So when you say you create this conspiracy theory and you have very strange piece of fact that, okay, this can't be true. And then you find, oh, this is true. Wow, if that's true and that's true and that's true, maybe this whole thing is true. But if you see all those little facts, they are so exceptional in the whole distribution, but people, when you see, just say, okay, if that's true, maybe that's normal, not exceptional. They don't see the fact as
that's what I'm gonna be talking about next, actually. So
okay, great.
That's a great segue. I'll just say that there are all of these different cognitive biases and behavioral biases. I'm talking about this overconfidence, and in relation to the Dunning-Kruger effect, but another one is this thing that is called the confirmation bias. And the idea, and there's actually, I typically, when I give the talk about those biases, I typically show a sentence from Francis Bacon 400 years ago, in which he says something like, when we find an opinion, when we create an opinion, we go and find facts to confirm it, and that's what we do. And if we don't do, and if we find facts that go against our opinion, we ignore them, or we find reasons why they're not good. And there are all of these examples of the confirmation theory. And one hypothesis, again, to be tested, is that the fact, for instance, that information is so accessible on Google or search engines, is that it makes you more it makes it, exactly like you were saying, easier for you to find things that confirm your own hypothesis. So this is another of the examples in which we are looking at cognitive biases, because we think that sharing of fake news is something that is very human. So it allows us to learn about humans and what makes us human. But we connect it to the rest, to what people see on the networks. And actually, I was going to talk about search engines next.
Just very quickly, I think that helps with my question. If were you just saying about the orbits of the sun and the Earth, if I know, because I've read some misinformation somewhere, that it's actually the sun that's going around the Earth, and I answer true or false to that question rather than don't know, how do you reflect that in your data? How have you unpicked that?
Yes, so that's a very interesting question. So there are these, okay, so if I understood the question properly, and if I didn't, please correct me. It's how the only questions that we are using are questions for which there is huge scientific consensus. Okay, so the Earth and the Sun example. We're not using questions that are kind of like the people might have doubts, or that the jury is still out scientifically. But it's true that if I can have wrong facts, right? So that I believe them, and so I give that answer. And we find that that is more likely in the controversial issues, and that's why we went to that paper, because people will truly believe things that are wrong about genetically modified foods or vaccines and things like this. Right? So this is what actually they know. So in our data we can distinguish, right? Because we are using issues that are not controversial, and that we know that there is consensus, so that there is there is something that is correct and something that is incorrect with very, very, very little doubt. But there are a number of papers that look exactly at what you are saying. And the idea is that the more controversial they are, the more likely it is that happens, just basically because there is more information around possibly. So more people are discussing it, there's more disinformation around, so it's more likely for people to have wrong opinions that they think are facts. And then there is a specific paper that, or not a specific, but a specific line, not a specific paper, a specific line of work that on climate change, where what they see is that, this is Kehan mostly, what he sees is that people will know the facts, or they will know the scientific consensus. For instance, if I ask, what is the gas that scientists believe to be involved in climate change, they will put CO2. They will have the correct answer. But if I ask, do you think CO2 is plays a role in climate change, they will say no. Okay. So the discriminating between what people know in terms of scientific information and what people believe is an interesting question that we're not touching here, but other people have. Okay, so and again, the questions that we have here are very like, what is the scientific consensus type of question. Okay, but when we repeated it for the controversial issue, we see the same pattern of we replicate the Dunning-Kruger effect only if we don't bin the data. Or we replicate only when we bin, only when we do it in quartiles. Okay. So this was a little bit what I had to say about the type of work that we do on the human susceptibility. And I'm going to talk about a very preliminary. So this one is really, we expect to submit soon. There's already a preliminary version on archive, but this one is very, very new. And I really hope you can get, I could get some ideas or feedback from you, because we're struggling with some things that maybe you could help. And it was actually inspired by a paper that Diogo presented to our group quite some time ago, and from other work from the Flamini and Minxer groups. So this is the idea that we know that we're increasingly living on networks, and that we are very connected to each other, and that we can even create these sort of like bubbles or information bubbles in which we only see information that is very related to what we want or what we see. And this has been mostly studied from the social network perspective. So the idea that our likes, our previous interactions alter our feed, and we see information that is the information that we want to see, to create kind of like a feedback loop, a positive reinforcement system in which the more you see what you want to see, the more you see, and you have the attention market, and you're probably all very familiar with this notion of information bubble. That is, again, debatable, but that's the concept. And what we think is that there's much emphasis being given to social networks, which makes sense, but much little to the rest of your experience, and exactly like the example that Diogo was given of search engines. So how much does your browsing history influence what you see when you go online and you search online? So this is adapted from this paper, in which this group did was that they looked at the past history of browsing, and they saw what they were being directed to. So that it's unidirectional in the sense of like, where does Google or Yahoo or Ask direct you to in terms of sites? Or the same thing for social networks. Where do these different social networks direct you to in terms of sites? And they found that social networks are more biased in the sense that they would direct you more, each circle here represents a website, that they would direct you more to a smaller number of websites that were much more likely for you to visit when you left than the typical search engine. But what we asked was something a little bit different, okay? So what we asked was, how does our browsing history, so what we've seen in the past, influence our bubble outside of social networks, okay? So do we get differential exposure to certain content depending on our browsing history? What does Google show me depending on my cookies, basically? So, and we know that sponsored ads are related or are a very good way of making money, even especially for these platforms, and that they are dependent on the browsing history. So what we care about is in the context of this information. So what happens, how is the browsing experience different if I'm an avid consumer of this information or if I'm not? So Diogo and I didn't agree on the question before, but it almost feels like, because it's such a good segue. Okay? So what we're trying to do is we're only looking at this part of the search engines, not this part. And what we're trying to do is in a way reverse the arrows. Okay, so how does my past browsing history influence what Google or the search engines are going to show me? Actually, here on search engines, we include YouTube as well. And this is the work of José Reis and Iris Damião. So José has a background in law, is about to finish his PhD in law, and Iris has a master's in biomedical engineering. So we really have people in the group from like law, psychology, neuroscience, but also physics, computer science, biology, the math, very different areas. Okay, so this is the work that they've been doing together. So and the question is, how does our online activity influence our bubble in general terms? This is very preliminary, but I want to guide you through the experiment that we've designed. And then I want to show you just a few results that you should take with lots of grains of salt. But if you have feedback, it will be very appreciated. So the idea is the following. We created a lot of bots Okay, and these bots, what they do is that they either go to a list of websites that we have classified by either by JDelt or Alexa as being real news, okay? Or they go to our fake news database that we've been collecting from many different websites and different sources. And these bots, what they do is that they go to this news or they go to this news, okay? And we can control for, and we have these two groups. So our treatment, they go to a random sample of fake news, and the control go to a random sample of what we think are not fake news. And then, and they can have, the results I'm going to show you all have the same geolocation as being all from the United States, but we're already doing it from different locations. And the results I'm going to show you, they ran sequentially, but very close together, and are moving into parallel because we found small differences in timing if you do it at the exact same time or right after. Okay. Then the second step is that we take these bots that have been browsing happily, and we do what we call the tracking audit. So we collect what the requests that they receive and the cookies that are put on their profile. So they have these profiles from their browsing history, and we try to collect as much as possible. Third party, first party, with the requests, with direct responses, and we also identify the ads that they see. Okay, we still having some problems here, but the idea is that we'll identify all of the ads. So we create this profile of what they saw and the cookies that were put on them. And then the third step is, so the first they travel, then we see what the online history looks like and what was put there, and then we do the audit. Okay, so then they go to different search engines, they type queries, and we see what the search engine gives back in terms of either autocomplete suggestions. So as the bot is typing, we'll see what are the autocomplete suggestions, and then the results ranked for the different search engines. Is it more or less clear? So these are preliminary results, like I was saying, but the first thing that we found, so still on this first step of the tracking audit, is that the bots that were visiting these information websites collected more cookies than the bots were visiting. So just in terms of number of cookies, then I have some breakdowns for the types of cookies and for the third parties. And probably it's not very surprising to say that we found a lot of Russian websites and websites related and cookies and third parties related with Russia. And okay, so this is for the true, and this was the false, the ones that visited true or false websites. And then we went to the search engines, and this is just for the results. I'm not showing you the autocomplete. The autocomplete are a little bit more complicated to explain, but the results of the autocomplete are even more different. But what you have here is for different search engines, and I think we are doing 6 or 7 different search engines. You do the same query. Okay, so the queries were either chemtrails, Crimea. Here I'm showing you things related with conspiracy theories. Chemtrails is this idea that the planes, the tracks on the planes that you've seen are when a plane passes in the sky and then it leaves these tracks, there is chemicals that are being thrown into space for some unknown reason. Crimea, that is now very what we're talking about. Then also the query liberal elites, and then the query vaccine hoax. Okay? So as we are typing, we see what are the autocomplete, but also what are the rank results. And the green line marks the results after the first page. Okay, so people typically say that if you want to hide something, hide it on page 2 of Google, right? So because no one goes there. So we compare the first page and the second page, but we go up till I think 8 or 10 pages and when we look at the ranking. Okay, so what you'll see is that for some of them, so for instance for Google, there are very few differences for any of them for the first page, and then you start seeing more differences on the second page and after that in terms of the ranking. For others like Yandex, depending on the queries, you can see a very different profile, and for the autocomplete they are even more different. They are completely different almost for all of these, including Google, and we also include YouTube. Okay, and then if you look at the content of what are these pages, so are these pages of good quality or of poor quality, and this is the last thing that I'm going to show you, what we see is that this is the proportion of hits that are in the low credibility domains. Okay? Then we use Hoaxy and we use our own database and we use different data sets to classify these as low credibility domains. And what you'll see is that whether they went to true websites or to false websites, the proportion of low credibility is relatively high. So it can be between 5, this is 15% here. But in some of them is quite high, and typically, except for one exception that is not significant, for most of them, the ones that went to the false websites are the ones more likely to see low credibility. Okay, so this is very preliminary. I wouldn't care so much about these numbers because we're still playing with the timings, we're still playing with many of these different things, but comparatively, just like not if ignoring this is comparatively, we see that some search engines seem to be better than others, and we also see that the ones that have false, they have cookies or information that was put by browsing into false false news websites will have not only different ranks, but they will also see different quality results. Okay, so to sum up this part, we have designed and have started to implement an experiment to audit tracking and its influence on search engine results. We found that so far, preliminary, disinformation websites tend to place more cookies, or bots that go through disinformation websites tend to collect more cookies. The profiles and the browsing history influence search results, both query and autocomplete, and some search engines might be more worrisome than others. And the profiles that visit the disinformation websites are more likely to be directed to poorer quality content. So what we're trying to do now is running many of these bots in parallel, increasing the number of geolocations, and also we've run into a lot of difficulties in analyzing the ads, and now we are very confident that we can extract the ads from Google, but we are working on the other ones. So again, if you have feedback, it will be very useful. So to sum up everything, and then if you still want to ask some questions, I've shown you a little bit of the work we do. Maybe Diogo will invite me in a couple of years to show how we're trying to make it all connected on this part of understanding this information, both from the host perspective and from the environment perspective. So thank you very much for your time, and you can follow us.
Thank you, Joanna. Very interesting. So regarding this, if anyone has a question, just put on the chat or raise your hand. But while you're thinking about your question, I'm going ahead and make my first question. So you said that there are some controls in the last experiment. I didn't understand, like, for instance, do you also, for each one of these websites or query that you do you have a totally unbiased version, like to get the ground truth? Like, for instance, if I have no cookies at all, if I do the search, what I get, like, because I imagine that if you're searching for something that is already fake or some conspiracy theory, you expect to get results that are somewhere more related to that. So I'm curious to see what's going to be like the baseline and then how much deviate from that.
Yeah. So the assumption that you just made, right, that if you visit fake websites, you're more likely to see poorer content. That's what we're trying to explicitly.
No, not the fact that I'm asking about like the query terms, like you're searching for something that is already fake, not necessarily if you visited before or not.
Yes, so I'm showing you results from conspiracy theory, but of course we need to search for very neutral things or for things that are not. And the other thing is that there is one bot missing here, of course, which is the bot that has no history. Right. So there's a bot that doesn't visit anything or uses or one of these bots, but uses an incognito window for the searches that will have a blank slate, right? They'll be clean, so it shouldn't influence. And that's of course the baseline, like you were saying. So both controls are very important, and yes, we are working on that. Right? It's something that we do. The searches with no history, and then many different types of searches. Some of them that are related to conspiracy, which is the ones that I've shown you here, and some of them that are not related to conspiracy. But if I search on Google for chemtrails, the first hit is Wikipedia. Right? So, but if other people search, or if I have a different history, what would be my first hit? Okay, so that's a little bit what we are trying to explicitly test, because we're really trying to understand if the same bubble that we discussed about social networks, like you asked, do we also get it just by browsing? Do I keep seeing also from Google and from the search engines that I use things that are poor quality information, so that could possibly confirm my biases or confirm what that I actually believe that I think I know what I'm talking about.
Very interesting. So any other questions? Already a little bit over time. Yeah, we have one question here in the chat. So how are you taking into account that some search engines will already block out fake news topics from the results?
So the fact that we see, so here I don't have the ones for the autocomplete, but so the fact that, for instance, for a vaccine, Google is very good, right? We don't see much, and and for instance, for chemtrails, we couldn't find anything of low credibility websites in that page. Google did not, on the query, Google for either of them, Google did not provide any of what we consider their low credibility scores. So the effort of blocking these sites or blocking these URLs is somehow working for some of the search engines, not for all, but for some of them is working. But for others are not so well. Right? And this is exactly what we're trying to audit. We're trying to understand how good they are and in which situations they are better or worse. So there are going to be differences, and we're interested in those differences, because we think it could help, right, to block this information if needed, if they can identify the blind spots.
Yeah, I have one more question, Massimo. Do you think search engines could implement some relatively easy defense mechanisms for hampering the diffusion of poor quality content? What would be the interplay between the need to fight misinformation and ethics of it?
Yeah. So for instance, Google, so these GDLs that I was talking about, the data set is already curated by Google. So Google curates false and real news. So many of the URLs that we use for our low credibility score have already been fact-checked by Google. So the easiest way would be, okay, URLs that are from this list, we never show them. So we think that they are low credibility, so we just don't show links from this. But now the interesting question enters, right? So the interesting question is, who gets to decide what are these low credibility? What are the biases in classifying them? How can we be fooled by this sort of evaluation, and how can we increase the bubble by eliminating a lot of the information that it's never going to show up, right? So I can give you a personal perspective, but I don't have any scientific basis for it, but my personal perspective is that we shouldn't let these decisions on the hands of the platforms. I think we can help and have systems that will help them define which ones they see or not. But for instance, one of the things that we use is the EU versus Disinfo, which is an initiative of the European Union to try to identify disinformation and block it. Again, probably very not surprising now. Most of it has to do with Russia or came from Russia. And but we need, in my perspective, we need institutions that that are accountable, that are transparent, that were selected by elected officers to do this sort of information, and we should not rely on the platforms to do it only, or we should not rely on their criteria. I don't know if I answered your question, but this is my personal view on the politics of this.
Okay, Joanna, thank you so much. We are way over time already. I know that there are people still making questions, but thank you so much. Hope you have more.
Do email or reach out through Twitter, and I'll try to answer them.
Okay, thank you. Thank you so much, and see you around probably when you have the final results of this. You can come back and talk to us.
Thank you very much. Thank you for listening.
Bye-bye. And thank you everyone who showed up today. Bye.